All right, this is the Math Models Unit 1 Lesson 8 video. This video deals with slope and intercept of linear functions. This should be hopefully a review for you. It's something that probably gets covered in every math class in high school at some point on some level. And so just to kind of begin, let me open a new note here. We need to talk basically about what those two terms mean. So slope and in particular y-intercept, but also x-intercept. So the slope. In general, when I look at a line, we're talking about linear functions. The slope tells me about what is the change that is occurring to this line. So the slope of this line that you see in purple is different than maybe the slope of this line you see in blue, because the slope of the purple line is going quite a bit more up for every amount it goes over. There's a different relationship between what we call the change in y, delta y or change in y, and the delta x than there is between this change in y and this change in x. So the relationship between these changes of x and y are different. And so the slope is a way of talking about that. It's a number that tells us about the change in y divided by the change in x. That's what that symbol there, that means change. You'll see that in physics, chemistry, lots of math courses. You'll see that symbol. It's the Greek letter delta. It's just a triangle, and it means change. So the slope is a way of thinking about how much this changes. The y-intercept and x-intercept are real similar concepts, but let's say I have my x and y axis, and I graph a line on that, like right there. The x and y intercepts are these points here and here. This point is the, sorry about that. This point is the y-intercept. This point is the x-intercept, because the y-intercept is where it crosses the y-axis, and the x-intercept is where it crosses the x-axis. So whatever this number would be on that axis, that's the number for the x and y-intercept. So what's nice is that all of this can be found really easily on a graph. So if I graph, for instance, and I don't know where there it is. Okay. If I graph the function y equals 3x plus 7, and I look at this graph, I can easily find my x and y-intercept. Those are always going to be given to you when you graph a function on the Desmos system. So my y-intercept is 7. It's right here, because that's the y-axis. And my x-intercept, is going to be negative 2.333. That's my x-intercept. So you might be wondering, well, what about the slope? How can I tell the slope from looking at this graph? Well, I'm going to zoom in a little bit. Oops, not what I meant to do. Let's change that. Let's zoom in. Okay. What I'm going to do is talk about how we find the slope of a line. Let me go over here and talk about, so you see right here and right here, the line crosses at an exact point. So just for the sake of helping you guys see that, I'm going to put those 2 points in this. That is the point negative 1, 2. Oh, no, sorry, it's not negative 1, 2. It's negative 2, 1. Negative 2, 1. You won't have to do this. I'm just doing this to show you where I'm talking about. And the point negative 1, 4. There we go. So you see this black and this red point. And when I want to find the slope, I need to identify two numbers. I need to identify the change in the y value and the change in the x value from this point to this point. So just plain and simple, this goes up 3 spaces and then goes over 1 space. And so the slope of this line would be 3 over 1, which you'll notice is right here. I'm going to talk about that in a second. But the slope of this line is 3 over 1. So let's jump back over to our lesson and let's talk about what this means for us. The first thing it means is that if I have an equation that is in this form, we call it the y equals mx plus b form, then the m is the number that represents the slope, and the b is the number that represents the y-intercept. There is not a number in that equation that represents the x-intercept, but these numbers represent those values. So that means that just by looking at this equation, which was the equation I just graphed, I could have known that the slope, or the m, sorry about that, equals 3, that's coming from here, and the b, which is the y-intercept, is equal to 7, that's coming from right here. If this was minus, that would be a negative answer. So I'm kind of giving you a lot of information about how to do this and where to look. So the equation is one place to look. Obviously, the graph is another place to look, and we already talked about how you have those points already there for you. And then we talked about how you can count the slope by finding places on the graph where it crosses, like right here and right here, and just counting the difference. So let's look at a couple examples from the actual lesson. So this is what they have you do. In every single one of these examples, they're going to give you an equation. They're going to ask you for slope, y-intercept, x-intercept. That's this whole lesson. And there are some questions at the bottom that are more vocabulary questions. So you just need to look at the vocabulary portion. And I'll also post a little guide for the basic ideas behind slope. And it'll make sense once you see it. But let's just say we get number 1 here. Y equals 3x minus 4. We're going to hop right over here, and we're going to do y equals 3x minus 4. Okay, right off the bat, I can find my x and y intercepts. I have a y-intercept at negative 4, which is that's c. And my x-intercept, let's go look at that. It is 1.333. So let's go see if we think one of these is correct. Well, that's definitely not 3. We already used answer choice C. So really B is really the only answer that makes any sense. And that is equivalent to 1.333. And I could find that by just coming over here and typing 4/3 and seeing that it does equal 1.333, which was the value of that point. So that's going to be my x-intercept, answer choice B. My slope. Well, obviously there's only one number left to pick, and it's 3. But let's talk about y. Again, if I come over here and I look at my graph and I start at a point, I can even use that one if I want. It goes up 1, 2, 3. It goes up 3 units over 1 unit. 3 over 1, and that's where we're getting the answer for slope, which is 3. Notice there are none and undefined as answer choices. Undefined is going to be when your line looks like a straight up and down line. Okay, and again, I'm going to post information about this in the notes. There will be a diagram that shows the 4 basic slopes that can be. I'll actually just show you right now. So there's 4 basic slopes. Let's draw 4 graphs here. You can have a positive slope, a negative slope, a zero slope, and an undefined slope. Positive slope goes up from left to right. Negative slope goes down from left to right. Zero slope goes straight across. Undefined slope goes straight up and down. I'll put another version of that in the notes for you guys. But in general, that's when those two come into play. Let's look at another example. These are also all pretty straightforward, but then something changes with 5 and 6. But again, you'll get these. These are some of these special cases. It is possible that the none is the answer, remember, for either the y or x-intercept. If it doesn't cross the y-axis, the answer is none. If it doesn't cross the x-axis, then the answer for x-intercept is none. So you can have no y or x-intercept. So slope could be 0, or it could be undefined. And that's what I just talked about right here. Zero slope is a line that's just straight across. Undefined slopes are just lines that are straight up and down. But let's look at number 7 and 8. The rest of those are pretty good. But 7 and 8 are weird because they're not in the right format. But I'm just going to show you really briefly. Doesn't matter. Because I can type this equation, 2x minus 3y equals, or plus 3y, messed up on that, 2x plus 3y equals 4, I think it was. Yes. Look at that. The graph was able to graph despite the fact that the line was not in the slope-intercept form that we talked about earlier. Even though it wasn't in this form, it still allowed itself to be graphed, and I can still do all the same things I did previously, which is to say I can find the slope, I can find these y-intercepts, x-intercepts, and I can count the slope by going from one point on the graph to another, down and over. Down and over means the slope is going to be negative. So I better be looking for a negative answer when I go to my slope. And it looks like that makes it pretty easy because there's only one negative option in our answer choices. Okay, so I've given you a lot of information. I think that you will be able to do these lessons with that information provided, or these problems. As always, reach out to me if you have questions or if you need to go over it after you give it an attempt.